हेलो एवरीवन, दिस इज निहाल एंड आज हम डिस्कस करेंगे द सॉल्यूशन ऑफ 2020 पेपर 2 ऑफ मैथमेटिक्स ऑप्शनल यूपीएससी सिविल सर्विस एग्जामिनेशन. So it says that let Z be a finite cyclic group of order n. That is, Z be a cyclic group, order of G is n. That means Z is generated by a single element, let us say that is A. That means G will be of the form identity a square dot a to the power n minus 1. This is Z, and then we need to prove that that Z has phi n generators. Number of generators are equal to phi n. What is phi n? Phi n is defined as number of integers which are relatively prime to n and less than n. I is less than n, and GCD of I with n is equal to 1. That means I is a relatively prime to n and I is a positive integer. Then the cardinality of this set is equal to phi n. That is a Euler phi function. Euler phi function is defined as I belongs to positive integers such that GCD of I with n is equal to 1 and I is less than n. This is how phi n is defined. Now we need to prove that this is the number of generators of G. G is a cyclic group of order n, and A is a generator of Z, and other elements of G are of the form a to the power I, where I varies from 0 to n minus 1. So what are other AIs which become generators of G? If order of AI is equal to n, that is order of G, then AI also will also become a generator. So we need to find how many such i's exist such that order of AI is equal to n. And how to find order of AI? There is a formula we will prove at the end of the video. That is order of a to the power I is equal to order of a divided by GCD of I and order of a. So if order of AI is equal to n, then AI will become generator of Z. So how many such AIs are there? So let us find. If order of AI is equal to n, so put order of AI from there. So order of A divided by I order of A का GCD is equal to n, and order of A is equal to n because A is n generator. So n divided by GCD of I comma n is equal to n. N and n will be cancelled out. That means I comma n is equal to 1. That means those AIs, if order of AI is equal to n, then GCD of I comma n is equal to 1. That means if AI become a generator, it is relatively prime to n. That means there are phi n such AIs because phi n is the number of such i's for which GCD of I with n is equal to 1, and that is exactly the number of generators of group G. Because the if GCD is equal to 1, then order of AI is equal to n, then AI will become generator. Hence, the number of generator is equal to phi n. Now we used this formula that order of AI is equal to order of A divided by GCD of I and order of A. Let us prove this formula. Says if order of A is equal to n, then order of A to the power I is equal to n divided by GCD of I and n. Let us assume that GCD of I and n is equal to D, and n divided by GCD of I comma n, that is n divided by D, is equal to k. And this k, we need to prove that this is the order of AI, that is n by D is equal to k. We need to prove that this k is order of AI. So when we prove something as an order, that is order is the least positive integer such that a to the power k is equal to identity. This k is least positive integer such that when we operate a k times, then it will be equal to identity. Least positive integer means if there exists another integer m such that a to the power m is equal to e, then k will divide m. So these two things we need to prove. To prove that k is the order of a to the ai, that means we need to prove that ai to the power k is equal to identity. And second thing, we need to prove that if there exists an m such that ai to the power m is equal to identity, then k divides m. These two things we need to prove. Let us prove this first. ai to the power k is equal to a to the power ik. And what is this k? A to the power I into n by d. Since d is the GCD of I and n, that means d divides I and d divides n. That means d divides I. This will become an integer. Let us say this is k1. That means a to the power k1 into n, which is a to the power n to the power k1. Since order of a is n, that means a to the power n is equal to identity. That is identity to the power k1 is equal to identity. Hence, we have proved that ai to the power k is equal to identity. Now we have to prove second thing. That is, if there exists an m such that ai to the power m is equal to identity, then k divides m. Let us suppose that there exists an m such that ai to the power m is equal to identity. That means a to the power I m is equal to identity. We know that order of a is n. And if there exists an I m such that a to the power I m is equal to identity, then n divides I m. This implies n by d divides I m by d. And since we already assumed that GCD of I and n is equal to d, that means GCD of I by d and n by d is equal to 1. That means GCD of these are n by d and I by d are relatively prime. That means these two cannot have a common factor. This means n by d divides m. And what is n by d? It is k. That means k divides m, which we had to prove. K divides m. Hence, we have proved that order of ai is equal to k. That is n by d. That is n by GCD of I and n. This is what we had to prove. Thank you guys. You can join Telegram group to ask your doubts. I will be happy to solve your doubts. Thank you.